everybody. Tonight we're debating Flat Earth versus Globe Earth, and we are starting right now. With the Flat Earth side, thanks so much for being with us. WitsitGetsIt and Kai, the floor is all yours.
How's it going? So you want us to, we'll do our little opener right now, share the screen.
You bet. I'll switch it over for you.
There you go.
They can see it crystal clear.
All right, perfect. All right, so the Earth is a stationary geocentric dielectric plane. Don't make it weird. All right. So we want to go over a few little quotes. Let me start All right, so briefly, everything occurs as if the Earth were at rest. Physics, Henrik Lorentz, but he's just like one of the fatherheads of electrical field theory. What does he know? I actually can't read this because these people are in my way. Can I move the actual people? Just forget it. This is Einstein basically saying that every attempt on any terrestrial experiment to prove the Earth is spinning didn't work and was a negative result, but that's how we know the Earth is spinning. The data of Michelson Morley were almost unbelievable. There was only one other possible conclusion to draw, that the Earth was at rest. Another physicist, what do we know? This is an infamous Stephen Hawking's really smart guy. Is the Ptolemaic or Copernican system correct? All observations terrestrially show that the Earth is at rest. This is infamous physicist Stephen Hawking, but what does he know? Again, once more for the record, it has been shown at least 6 different ways this century alone that the equations in physics used by NASA to launch satellites are identical to the equations derived from geocentric universe. But there's no way the Earth could be geocentric. That's crazy. I can kind of remember this, even though it's, again, blocked. But today's scientists substitute mathematics for experiments, wander off in la-la land to where basically they end up with no relation to reality. And mathematical constructs, of course, aren't reality. So let's just see if NASA's a credible source, since they're the ones that give us all this mystical information about space and the Earth being a ball.
Your question that the sky is almost white with the light of the universe, with the uncountable number of stars.
The sky is deep black.
The sky is almost white with the light of the universe, with the uncountable number of stars.
The sky is deep black.
You can't see the constellations because the sky is just so alive with stars.
The most unexpected thing, I think, was the blackness of space. Most unexpected thing, I think, was the blackness.
So again, you're just going to hear more contradictions between the astronauts, whether you can see stars or not. You would think that they would all be on the same page and recall the same things if they went to the same place, but clearly there is a discrepancy. So we have more of this.
We were never able to see stars from the lunar surface or on the daylight side of the moon by eye without looking through the optics. I don't recall during the period of time that we were photographing the solar pearl what stars we could see.
I don't remember seeing any.
The sky is deep black when viewed from the moon, as it is when viewed from cislunar space, the space between the Earth and the moon.
And we cannot see stars.
It's not a black void. I mean, it's black, but there's all kinds of little polka dots.
There's all the stars there. And the cool thing is about it, you can see it during the day.
And when you're in space and you're looking into deep space and you're on the sun side of the orbit, the sunlight washes out all the starlight, so you can't see any stars, just like here on Earth.
There's all the stars there. And the cool thing is about it, you can see it during the day.
You can, and there's more than stars. You can see planets. You can see moons.
You see the gas Magellan clouds of the
So yeah, which is it? Do we see stars at all? Do we see them on the sun side or not on the sun side? So much contradiction does not make sense if they are all going to the same place.
Yeah, seems weird. They're all going to space, but they all have very different experiences that are directly contradictory. Here's some pictures most people have seen. This is an infamous scientific talk from NASA, and in the background it shows you this guy that's supposedly on the ISS is in front of a blue screen. Totally normal. And here's in the bottom right is NASA saying, which is a clip shot of an article talking about how they use virtual reality in space now. which is convenient because we've seen their hands go through coffee cups and lemons and et cetera. But
and that's how it looks like they're manipulating like water droplets or like floating pizzas or whatever shenanigans they have, but they're able to do it with such accuracy because they are using VR.
Yeah, and just to address, I mean, we're addressing the credibility of the primary source of all the stories of space before we get any further. So NASA also admits that they practice their spacewalks in a pool. They have a mock ISS in the pool.
Buoyancy lab.
Yeah, so that's pretty cool. Just practicing the pool, no big deal. But it appears that NASA missions halted after astronaut almost drowns, water covered eyes, nose, and ears. Here's another article. Astronauts keep almost drowning in space. And it does say keep for a reason, because if you Google this, you will find this story being told once every year for the last 5 years. So consistently, they can't figure it out. Mysteriously, NASA's astronaut suits keep filling with water in space. But of course, like we said, they do practice their spacewalks in a pool. So maybe they're in water. This is to address the claims of all the satellites. The biggest consumer of helium in the entire world is NASA. They consume about 90% of the world's helium supply. And of course, they have a satellite project. So most flat earthers do not deny that there's stuff in the sky. We just deny the claims that they're in a second law of thermodynamics violation. So we're gonna move on.
Oh yeah, these are apparently real pictures of planets, but clearly they are CGI, which same with the globe. There's only one real picture supposedly ever taken of the globe. Robert Simmons confirms this in an interview they did, that they use composite imaging and artist rendition. They take a flat map and wrap it around a ball and add in Photoshop clouds.
Right. So it's just 2022, but we have nothing but CGI. And if we deny this, then we're apparently crazy. So here's a video with, an actual video of what
with the
stars.
Nikon P1000, I believe.
Yep.
When you actually look at the stars with that versus using NASA's CGI.
Yeah. So the globe earthers will, of course, say that this is just not in focus, but it's very convenient that you can so precisely critique a shot with an actual camera as you tout CGI. So I think it's a bit of a double standard there. This is an actual verifiable video as opposed to computer generated cartoons. So I think that doesn't really make sense. I would probably pump the brake. It's just out of focus. It's out of focus. But anyway, moving on. Here's another video.
So what are the lights in the sky then?
This doesn't look like the CGI. And again, we always have to rely on a handful. And by the way, in the telescopes, I'm sure they're going to say, the telescopes are the same unless they have computer program rendering the image and it's layered. Mm-hmm. So again, that's not a real image. That's not a real picture. So what is up with that? Why is it that when we look at the actual pictures, they seem to show a totally different story? So like she said, I wonder what they are.
And what they resemble are cymatic patterns in water, which is where you take frequencies and then you were able to create this sacred geometry in water or sand. There's also an effect called sonoluminescence, where you use frequency in water and it's able to create a bubble. Once the bubble collapses, light emits. And this phenomenon is also called a star in a jar. So just if NASA is lying about these things in the sky, what could they possibly be?
Right. And this is just actual science, right? Where you can actually prove the phenomena. So if you manipulate a medium with acoustic introduction or frequencies, again, it will emit light. And they look identical to what we see when we look at the sky. So very interesting. Cymatic patterns seem to potentially be the source of the sky. So the entire conversation here is the Earth a globe or is the Earth flat? One of the primary things you hear a lot is, do you have a model? Do you have a model? Well, here we go. If we just use the actual phenomena that we can measure, the magnetic flux here, these are on the top, that's the magnetic flux. On the bottom, that's ocean currents. They map out perfectly on a flat surface. Of course, on the globe, they're all over the place. This was a very popular website, and it took the azimuthal projection down once people started finding out about flat Earth. On the right here, you will see that the sun rays, the direct 9-degree angle does not line up with the equator, which is the hottest part of the globe, which makes no sense whatsoever. Of course, on the flat Earth, it makes perfect sense. The temperature distribution is perfectly aligned with the position of the sun, just like when it's hotter, when it's noon. So, of course, gas pressure is the force of the gas particles colliding with the walls of its container. So, an antecedent to gas pressure is a container.
Gravity is not a container, not a physical container.
Although that is your replacement of a container. So here we have some proof of what appears to be the container reflecting light.
This effect is called a sundog. They say it's because there's ice crystals in the sky, but this phenomenon also can happen during the summer. Interesting.
Yep. I think we only have like a minute or two left. So real quickly, this is an electromagnetic field, which is what we have on the Earth. The globe Earth, according to Harvard, still can't even adequately explain how the magnetic field even exists or how it is distributed. But anyway, magnetic fields have what's called an inertial plane. So there's a depiction. You would live on that green plane through the middle.
Here's an inertial plane. Is the inverse to counter space, which of course is polarity, which is a three-dimensional S-curve. In other words, the plane of inertia, which is the inverse of magnetic centrifugal divergence, which of course forms the geometry of this. The toroid is a cross-section of a toroid or a donut shape. And this is of course what the magnetic field looks like, right? It's toroidal.
Right. So there's the inertial plane, which would again be where you live. I'm going to have to go through this pretty fast, so sorry in advance, but there's an atmospheric gradient on the Earth of electric potential. It goes up roughly 100 to 120 volts per meter. That results in a downward current on the Earth. So when people say something about gravity, actually, they're just hijacking the phenomena that we know is there. Is electric force stronger or weaker than the gravitational force? Well, it's 10 to the 39th power stronger than gravity even claims to be, and you can't isolate it. So how could you ever find out anything that was any weaker than that? So
it's not gravity, it's electrostatics.
So electrostatics, incoherent dielectric acceleration specifically, and Inner World Productions. I think we made the time pretty quick.
Thank you very much for that opening statement. And want to let you know, folks, if it's your first time here at Modern Day Debate, we are a neutral platform hosting debates on science, religion, and politics. We hope you feel welcome no matter what walk of life you are from. Flat earther, globe earther, you name it. We're thrilled you're here. And don't forget to hit that subscribe button for more juicy debates coming up. With that, we're going to kick it over to Taylor and Jen for their opening as well. Thanks so much for being with us. Defending the globe tonight. Taylor and Jen, the floor is all yours.
Thank you so much, James, Taylor, Witsit, Kai, everybody associated with the channel. Great to be here. I'm Jen. I'll be giving a defense of the globe Earth, and I'm really looking forward for the chance to be back on the show. I just want to say real quick that I appreciate the amount of scholarship that has gone into my opponent's defense of their position. I don't recall exactly how the last debate went, but it does seem that it's a lot tighter from the scientific persuasive angle. It doesn't mean I agree with you. And I'm looking at you, audience, all the people that said that I was defaulting mid-debate last time. That did not happen. That's just called having a good sports person-like attitude in debates. So back to what it is we're talking about here. And this is a bit of a touchy topic for me. This has frustrated me before. It's like, isn't it obvious that it's a ball? I mean, look, everything pretty much, if we just let it do its thing, it's a ball. But that's obviously not what our senses tell us. So we have a bit of a pull back and forth between an impression and measurements, and we have to use geometry, mathematics, and physical models to interpolate our way to a greater understanding. And that's where I like to invoke metaphors. What is this? It's a three-dimensional lens, and it's a metaphor both for our atmosphere and our consciousness and our eyeballs. What is this fundamentally doing? Well, it is pulling in a bunch of light to a more concentrated region. And I apologize in advance if my audio is not working out. This is a new set of headphones for me, so please bear with me. I'm doing my best to make the most compelling version of the arguments as I can kind of cobble together, because it's hard to put myself in the position of somebody who would be skeptical about something like that, just because isn't there already a sort of inbuilt skepticism just with the sheer relative size? if you're saying the Earth is flat, you're potentially saying that what your eyes recognize for something that's many thousands of times bigger than you is the accurate shape. Now, why would we expect the shape to be accurate when I just demonstrated 3 examples of lenses, atmosphere, consciousness, and eyeball? And none of those reflects what was originally put through, does it? I'm flipped upside down. What am I getting at here? It's about what's a reasonable place to begin. A reasonable place to start is, well, it's actually pretty much the only way to explain what we see here is with a globe. And if I may share my screen, I will go over to address some of these arguments. All right.
Crystal clear.
Okay, so is my leaked government document. And I just Googled this randomly, and I'm sure this is a bit of a straw person here, but just bear with me. What is this saying? I can totally see how, you might want to say, oh, well, they did a drawing, and therefore that's what reality is. But we're sort of missing the point of physics, which is to make models. So it is perfectly conceivable that NASA or others would be using something that looks like a flat Earth model, but that does not actually, nobody using that model actually believes that the Earth is flat. It's just the best approximation given the scale. And what does that mean just intuitively? There is no reason to think that we would be able to do multi-scale estimation. So we really have to completely trust a model on all the levels. So what this model might be telling us, I don't know if it's real, it's probably not, but hypothetically, let's say that it would be an approximation on that scale, meaning not more than 100 meters. If we want to take into account the scale of the entire planet, well, that's considerably bigger. So if we start with what's obviously a sphere, I've got this ball here. As I pull it away from the camera, it's a lot harder to tell whether it's a sphere or a circle. So there is an issue with spherical things at a sufficient distance appearing flat. And there's a question of what is it we can actually conceive of in terms of a model that is going to give us an accurate representation, that is going to give us accurate predictions of numerical values, and realizing that those two aren't the same. So the model that gives you the best numbers in terms of future values and the model that tells you the exact physics of what's going on, they may not be the same, and you may not even be able to have a single model for both because of the complexity of the cosmos. So I'm just throwing out examples here that even though it's a frustrating debate to keep on having, you can see why there might be misunderstandings, especially when we have the prevalence of beliefs that cogito ergo sum, and perhaps this is committing a bit of a reification fallacy with regards to the importance of sensory impressions. How am I doing for time, James? I feel like I've been really rambling here, and I don't want to go too long. All right, well, I have like pages and pages still to go here, and I know my partner wanted to wrap it up and go into the actual meat of the conversation, so I'll try to just skip through to whatever was I made a lot of notes about the presentation, so that Witsit and Kai put on, so I guess...
well, take your time if you feel like you need it. Don't rush on my behalf.
Guess I'll mention just quickly, thank you so much, about the moon, that there's definitely some mysterious stuff going on with the moon. And have a look here. There's really no reason that the moon ought to line up with the sun so perfectly as to create this effect. It's really quite something. And so I don't think that necessarily tells us anything about a physical model, but it's certainly an example as to how mysterious everything is and can precipitate this symmetry. And I think you mentioned also that there was no way to disprove that we were in the center of the universe. And findings like that, they're mysterious because I expect that because cosmology does tend to be mysterious. And that fact pretty much signals to me that it's another manifestation of the least action principle that's very ubiquitous notion that the amount of energy is always minimized over whatever field the vibration is taking place in. And so whenever a mysterious symmetry arises, I always think, okay, it's something connected to the least action principle, even though I don't know exactly what it is. Somehow it's coming together to create something beautiful. And I better not let my inclinations towards poetic interpretations take me off on a flight of fancy, because I am doing physics here. I need to really stick with not just good measurements, but a good interpretation of the measurements and acknowledging all of the evidence, but also contextualizing it. Like, what does it really mean that you saw those water effects on the I think you called it a sacred geometries. What does that really mean? Well, much more likely that that's a lensing effect either from the camera or possibly even the atmosphere. And so there's maybe some effects that are less well understood. For example, a snow dog could happen at any time. I think that's what it's called. The lens effect in the sky could happen at any time. It's really just not a triple point. Sorry. It's just a matter of whether it's at the right pressure, density, temperature point for that effect to happen. It doesn't have to be like cold or warm on the surface. That's an effect that manifests in the atmosphere, and it would be the temperature there that determined it. So yeah, the moon is really what sells me on Earth being round, because we don't see the moon all the time. It goes away, but we do see the same face of the moon all the time. So that's another mystery. But those two things combined, the fact that the moon is less privileged than us rotationally, in the sense that the face that if you were standing on the moon, you could eventually see everything on the planet, versus the planet Earth only sees one face of the moon. That tells me it has to be a sphere, because we would see it all the time if it was flat, I suppose. So I guess I'm done with my intro, and thanks for listening, and I'll hand it over to my co-debater. Thanks so much.
Thanks, Jen. And I'll share my screen too.
While he's pulling that up, I want to remind you folks, our guests are linked in the description. So if you'd like to learn more about the views of either side, you can by clicking on their links below. All right, Snake, they can see your screen as clear as day.
All right. Is the word tab showing up?
Yep.
Oh, okay. I'm going to be reading off that. Or do you see my text document, or do you just see the
right now you're
glow?
fully sharing your screen. If you wanted to click on a certain window to share, you could. You'd have to unshare and then go back to sharing.
Okay, sorry about that.
Not a problem. As mentioned, folks, they're
Screen.
linked
Oh yeah, I see it
down in the description. That includes at the podcast. Modern Day Debate debates are uploaded to our podcast within 24 hours of each debate, and we put our guest links in the description box for the podcast episode as well. They can now see a picture of a globe Earth.
Okay. So, so flat Earth is pseudoscience. It's fake skepticism. They accept photographs and tabletop experiments if they support flat Earth, but they reject photographs and valid experiments if they support the globe. They have an impossibly high standard of evidence for the real science, but will instantly turn on a dime and lower their standards if the same type of evidence supports the flat Earth. But you can't have it both ways. We have experiments proving how gravity works. Do they care? No. Do they have experiments showing how gravity works as they say? No, but they accept their conjecture as fact anyway. They'll speculate about some woo-woo electromagnetic whatever that might be responsible for suspending and moving the sun inside the atmosphere, and that's good enough. But meanwhile, rigorous peer-reviewed science is dismissed as a conspiracy. They insist that the sun is in the atmosphere, but will never send an expedition there. Any photographic evidence of actual expeditions to the moon are claimed automatically to be fake. So there's a double standard. Regardless, the globe predicts data. Flat Earth predicts none of the data. If you make predictions about reality, you understand how it works. If you can't, you don't. Flat Earthers can't even accommodate the data. They're actually so incompetent at this that they now avoid even trying to make a map at all possible costs, because all flat maps always contradict real-world observations of flight paths, star paths, land proportions, path of the sun and moon, et cetera, et cetera. Flat Earthers don't even have enough real confidence or practical skill to make a map, let alone send an expedition to the things that they claim are in the atmosphere, like the sun and moon, nor will they even try. To quote Kai, that's why we keep it vague. So it doesn't matter to them because all the evidence is a conspiracy. It's all lies, so they can just reject it out of hand. It has to be an impossible global conspiracy instead of facing the possibility that they might be wrong. When flat earther Bob Nodell bought a laser gyroscope to prove no rotation, then he measured a 15 degree per hour rotation. He dismissed it rather than accept the possibility he had no idea what he was talking about. When flat earther Jeranism proved water curvature with his own experiment, he dismissed it rather than admit he was wrong. Interesting. You also saw them in their presentation misrepresenting what physicists actually say about the subject, quote mining things, cutting things up out of context. So what are we supposed to do in the face of such reckless hubris? Well, what about that oft repeated phrase, replacement is independent of falsification, the excuse for why they can't produce a working map? The so-called falsifications come down to a few typical misunderstandings like why no one falls off the bottom, quote unquote, how curved water can be level, how the atmosphere stays held to the earth next to a vacuum. Properly understood, real physics like gravity explain all this and actually necessitate a globe shape, falsifying and replacing the flat earth at the same time. Flat earthers universally reject gravity, and it's for a good reason. If you understand gravity, you can't really be a flat earther. Okay. So a couple more slides here, almost done. Second point, other than gravity, I would like Kai and Witsit to explain how the stars rotate in different directions depending on the hemisphere, because it's not physically possible on any flat plane. And let's see. Oh, thirdly, the feed you saw for most of this presentation was the live feed from the Himawari 8 Japanese weather satellite, a non-NASA installation. And flat earthers can falsify it at any time. Just go find weather data that contradicts the unfakeable live feed. I can assure you they will not do this. And the only other photographic evidence I want to bring up is the photos of the curved water at Lake Pontchartrain. So let's discuss. Thanks.
You got it. And with that, we're going to jump into open conversation. Want to let you know, though, folks, as mentioned, a lot of juicy debates coming up that you don't want to miss. For example, at the bottom right of your screen, I'm pulling up this new one. Are trans women women? It is going to be a controversial one between Vosh and Dr. Bogardus as they collide next month. You don't want to miss it. Hit that subscribe button. With that, we're going to jump into an open conversation, as mentioned. Thanks so much. Austin, Kai, Taylor, and Jen, the floor is all yours.
Okay,
So-
you keep on talking about experiments, so I think Kai has a question for
Yes,
you.
we have a question for Taylor. So Taylor, what are the 3 constituent parts of a scientific experiment?
Well, you're looking for a specific answer, so why don't you tell me?
We're just
So-
looking for the right
Well,
answer.
yeah, because you think
Let's
that
just
we
talk
don't
about an
care
experiment. Let's not waste time. Let's talk about Cavendish.
Okay, so I will answer the question that you can't answer. You have an independent, dependent, and control variable. Okay, and the crucial part is establishing cause and effect. Okay, that's how you conduct a scientific
Right. So let's talk
experiment.
about Cavendish
Now,
experiment,
before
cause
you
and effect.
before you interrupt me, so when we're talking about gravity, that means you have to, if gravity, space-time has to be the independent variable, you have to be able to manipulate the independent variable. And that is not what the current science, which is actually pseudoscience, is ever doing. So
No, you don't. That's just a lie. So let's talk about the Cavendish experiment. You don't need to manipulate all those things.
Cavendish wasn't trying to prove gravity, but go ahead.
Yes, it does. It proves that there's an attraction between masses, which is gravity.
Cavendish wasn't trying to prove gravity.
It doesn't matter what he was trying to prove. It matters what the experiment shows, and the man Cavendish is irrelevant. So what does the experiment show? It shows an attraction between mass. End of story.
No, it doesn't actually.
Yes,
It's actually very inconsistent. So are you claiming that you always get the same results?
No, that's the point of experiments, is you can repeat them.
Right, as less
so
than a 10%.
Sometimes the experiments have errors. There's a torsion element to it. Some people get the torsion element wrong.
Okay, so but
you can't have the string have any torque in it.
Do you agree that if you do an experiment 10 times and then you only get the right result one time and you dismiss the other 9 to user error and just cherry pick the one out, that's not actually science?
So 99% of the time you get the same answer, and it's mass attracts mass.
That's incorrect.
Which is not even, which has also been superseded by Einstein, which is now the bending and warping of space-time.
No, Cavendish was not overturned by Einstein. They still use that experiment.
Newtonian physics. So you said mass attracting mass. That's saying that gravity is an intrinsic property of matter. That's Newtonian physics. It was superseded in 1915. Gravity is no longer considered an intrinsic property of matter.
That's fine. There's still an attraction between mass.
Well documented if you just research it. I can pull up some academic quotes for you if you would like.
There's not an attraction.
I remember you mentioned something about a stationary plane and a dielectric plane. Would you?
Yeah, where's the experiment for that?
Wait. Before that, though, would you like to concede that?
Absolutely not. You're lying right now. That is a experiment that absolutely shows attraction between mass and mass. When you put two heavy masses next to each other, they will always be attracted to each other. And you can take out the many variables. That's what the torsion bar is for. You take out the variable of spin and torque. You take it off the ground. You take out the variable of friction. So anytime you put two masses next to each other, they will attract each other. You can switch them, and the experiment will spin the other way. You can put the masses on the other side, and it will immediately be pushed to the other side.
Okay, again, you're just saying that, but I've actually researched it in depth. It does not consistently work. But the real problem, I'll just go ahead and cut this off.
You're lying.
I'll go ahead and cut this off at the head for you, man. You didn't control for the variable of electrostatics, which is 10 to the 39th power stronger than gravity. So even if it was consistent, which it objectively isn't, the attractive force there that's objectively and measurably there is 10 to the 39th power stronger than gravity. Can you rebut that for me?
Yep, because you can you can test for that.
The actual physical answer there, if you want to get technical, is that gravity acts over 1 over r squared, or falls off as 1 over r squared, and electromagnetism falls off as 1 over r cubed. So what you see is exactly what you'd expect, but you have to interpret it correctly. It's a
electrostatics.
Why are we even able to stand up? I mean, let's, give the globers their, give them a chance. Like, if they're right, basically what they're saying is that we have this big globe and we're sucked into towards the center of it because it's so massive. And then the question becomes, well, why aren't we just a big flat pancake on the ground sizzling? And the answer is because we have electrostatic torsion holding us standing up. I mean, in a way, it's a bit of a miracle that we're able to stand up and ambulate so easily. Ask anyone who's trying to program a robot to walk, and it takes them a really long time to get the thing not to just fall over in a ball. I'm being a bit hyperbolic here, but just so you know, the electrical gravity torsion, equilibrium point, that's exactly what you would expect for a globe. It's just that when the gravity force is 1 over r squared versus electricity is 1 over r cubed. So in very close distances, electricity is much stronger. Over longer distances, gravity is stronger. And
but
then they have a balance point.
That's called a begging the question fallacy. So we're actually disputing that very thing. He just invoked Newtonian physics, which is
I didn't.
over 100.
You're lying again.
So are you saying Einsteinian physics is mass attracts mass?
That is an observable fact. Whether you're in Einsteinian physics or not.
Does the theory of relativity say that mass attracts mass?
No.
No,
Okay,
but it
so
doesn't
because
falsify
that's outside of
necessarily the
theory of
Newtonian.
relativity. The theory of relativity
Wow.
doesn't say the
I
sky is blue either.
can't hear Jen's rebuttal.
Okay, so what you're saying is that you're trying to prove a gravity that was proven to no longer work in your model, and it had to be updated to the theory of relativity.
It didn't have
Is
to
that
be
what-
updated. Mass accelerates towards mass.
mass
That
no
was
longer
not
attracts
overturned
mass.
by Einsteinian physics at all. And it doesn't matter if it's
explain it.
electrostatic or not. Mass
Okay,
accelerates
first-
towards mass, whether it's
Okay.
electrostatic or not.
Okay, yes, I understand. First of all, gravity is the effect of the bending and warping of space-time according to the theory of relativity. That has superseded Newtonian physics. The reason electrostatics is
Irrelevant for
important
the
is
purposes
because
of the debate.
well, you're trying to prove something that doesn't even happen to exist in your model anymore. So
And if we're
No,
going to
that's a
discuss
lie.
gravity,
It exists.
if we're going to
Gravity
discuss
exists in
gravity, we
Einsteinian
need-
physics. Stop lying.
not mass
Go ahead.
attracting mass.
I want to be sure we hear
Mass
from
accelerates
Kai.
towards
Just as
mass,
it's-
yes.
Just to hear, sure we hear from Kai. It sounded like you had something to say, Kai.
Oh, thanks, James. All I was going to say is it's absolutely applicable. If we're going to be discussing gravity, we need to understand the supposed cause. So
No, you only
bending-
need to know its behavior.
the cause, the bending and warping of space-time.
Yeah.
You only need
So
to know
how-
its
so what's-
behavior.
So here, let's ask this question. So you said that gravity's been proven over and over by scientists. Can you describe the difference between correlation and causation?
Causation is something that is caused by something else. Correlation is just appearing at the same time as something else in the data.
And how do you differentiate between the two in the academic world?
You eliminate variables.
You have an independent, dependent, and control variables. And the key part is to manipulate the independent variable and see if it affects the dependent. So when they were studying gravity, we're going to use Einsteinian gravity because that is the most current explanation. What was the independent variable and the dependent variable in that experiment?
In Cavendish,
No, when they actually proved Einsteinian gravity.
I don't know. I don't know
Bending
that
and warping.
experiment.
That's the foundation of everything, according to you.
The
Great,
Newtonian
irrelevant for the
work.
debate.
No, Newtonian didn't work anymore. They had to update it to Einsteinian
I'm-
physics. Are you not
I'm not talking
aware?
about Newtonian physics.
Mass attracting mass is Newtonian physics. And actually, hilariously enough, Newton said, please do not attribute that to me, because the idea that innate brute matter could attract innate brute matter and act on it through the vastness of a vacuum is to me so great an absurdity that no man with competent faculty of thinking and philosophical matters
Good
could
for
ever
you.
follow.
Okay, so
That's his
mass
word.
Why do you
moves
interrupt so
towards
much, bro?
mass.
Why do you interrupt so much?
Why do you just waste time so much? Mass attracts
Just
mass.
in case Jen has anything to say. We haven't heard
You can-
from you in a while, Jen, in case you had anything.
I think you may be
Jen,
muted
you're
now.
muted. Wait, you're not muted. It shows you as unmuted, but we're still not hearing you.
Coming
This is the
through.
best glove argument I've heard all day, James.
No, that's it coming through. Did I
Now we
accidentally
can hear
mute?
you.
I'm so sorry. I got excited there. So perhaps my last few arguments were missed. But thank you for calling attention to that. I was interested about one of the arguments in your opener, which is just maybe taking a new direction about, you mentioned that you can't see the stars. Now, just to clarify, is the claim there that you can only see stars within the Earth's atmosphere, and once you're like too far, it's blackness or something? What could you refresh my memory as to what the claim actually is about the
That's a great question, Jen, because the claim is not consistent. So we'll start with Neil Armstrong. At first, they say that because of the glare of the sun, you cannot see stars because of that. Then he, in another interview, he says that the sky in space is a deep black from the view of the moon, and also cislunar space, which is the space between Earth and the moon. So that is the original claim. Now that has been updated with recent astronauts that have gone to the ISS. Some of them say we can see stars, whether we're on the sun side or not on the sun side, whether it's day or night, we can see stars all the time. it's the one astronaut said it was so bright because of the stars, it's almost light. But then other astronauts on the ISS say it's a deep black, that there's no stars. So it doesn't stay consistent. We don't actually know the real answer because these astronauts, both astronauts that have been to the ISS, the same location, have different recollections of their eyewitness testimony, which in a court would be very suspicious and should be treated the same.
Yeah, so what's happening is they're just lying again because they know that they're taking these statements out of context. You can look in a particular direction and you will be blinded by the sun. You can look to the right and you will see the blackness of space and stars. It's like looking into a flashlight. You can't see the flashlight, but if you turn to the side, you can start seeing things again. And you guys know what you're doing.
Don Pettit said, we're not lying. We actually just
played it for everyone to listen to it, dude.
We did more research than you did. We didn't have to read from a paper or anything. So,
no, you clipped it out.
So Don Pettit said,
I'd like to respond.
Okay, you call us a liar, but I mean, we played it for the audience.
And you need another word.
If I wanted to take a page out of your book, I'd take the next minute to blow you about how only the stupidest, dumbest, most idiotic could ever believe something like that. It's true, but I won't waste time like that.
That's what you said in your argument.
So no, I described what pseudoscience is. So when you take clips of people saying, we can only see the blackness of space. And then you take a clip of someone saying, when you're looking at the sun, you can't see stars. You're quote mining, you're taking out the context because there are certain directions you can see stars, certain directions you can't see stars.
We just
remove that context. You removed the context. Correct.
We just played a video. And one of the astronauts says that during the light of the sun, you can see stars. And one says that you can't. So you're wrong.
No, because it depends on which direction.
No, they said even during the day. They said even during the day.
Right. Which is why you trim the context, because it matters whether you're looking at the sun or not during the day.
But so if you're not looking at the sun, you can always see stars in space.
It depends.
Okay.
Then you would disagree.
Depends on
with
a lot of different factors, which you cut
There may be two effects. Are you familiar with something called a snow blindness, or it's an effect when you go skiing? Like this, there's a reflection off the snow, and the sun sort of blinds you. So anyway, there's all sorts of different effects that can happen with. I guess it's probably a bad example, but.
We're just pointing out they have contradictory statements. He's trying to say that we're misrepresenting them. We played it for them. I encourage everyone to go look at it.
It's possible that within the atmosphere, there's more twinkling caused by the atmosphere itself. It seems maybe that you're having trouble understanding how there can be an atmosphere. Did you give any thought to what I said last time about the moon being the thing that's holding the atmosphere in place?
That sounds wild to me, but.
It's totally wild because we have to contend with what are apparently contradictory, but not contradictory boundary conditions or binding principles, which is the speed of light is 3 times e to the 8. So that's like 3 with 8 zeros meters per second. And that's a very fast compared to the speeds that we're used to.
It's a global
sorry, go ahead.
Global conspiracy, but they can't get their story straight somehow.
Stop self-projecting.
Yeah, our story or the astronauts who literally say you cannot see stars. Okay, and these are just a few of, there's so many of these clips. They say you cannot see stars in space.
It's called a hostile witness, bro.
But if you were looking at our star, because it's so close, our sun is so close, okay? If you're looking towards our sun, you're not going to see behind it because all the light from the sun is going to be glaring in your face.
And Don Pettit literally said, even when they're looking at the sun, they still see stars.
You can see all of them.
That's what they're saying.
Said when it's daytime. So.
Wait, okay, whatever. I have to address something because my homie Bob, right? So you just now said that whenever he used a gyro and he found the degrees, he didn't want to accept it and he dismissed and all stuff. That's actually just patently false. So what happened was he actually ended up taking the gyro to different altitudes at the same latitude and got over a degree in variance. So would you agree that if you use a gyro to detect the axial rotation of the Earth at a certain latitude, but then you change altitude and then the degree changes, that refutes the idea that it's because of axial rotation?
No, because you're still measuring rotation.
At the same latitude, it's just...
Since you clearly have never done any science at all,
Ad-hoc.
You've never had to calculate your. It's not. You've never had to. You're clearly demonstrating you don't understand what a margin of error is.
No,
but
can
if
you
there's
answer the
rotation
question?
measured, I did. I said no. If there's rotation measured, then rotation is measured.
Hey, but
Doesn't
would
matter
the
if there's a
rotation
margin of
change?
error.
Would the rotation change if you keep the same latitude on a globe?
It could. Was he in a different location on the globe?
He was at the same latitude.
But I thought you had a bunch of quotes before saying all these physicists couldn't distinguish their measurements from a flat stationary surface, and now you're saying you can.
That's
measure.
true, but this guy claims that the gyro proves the Earth is spinning. So I'm going to see if he even understands why. So on a globe, there's latitude
do you cite
lines.
that?
On a globe, there are lines of latitude, and the Earth spins at different rates based on the size of the sphere. So if you stay at the same latitude, then this axial rotation remains the same no matter where you are on that ball if you're on the same latitude. Isn't that right, Taylor?
Nope. And Bob, he thought it would. Yeah, you're just wrong. There's a thing called margin of error.
Margin of error. You're vaguely.
I'm not done with my statement. So, Bob, before he did the experiment, said that this machine will work if it shows rotation. Then that shows rotation. If it shows degrees of rotation, then that shows the rotation of the Earth. Then he changed his story. He said, "Well, it's the degrees of rotation changed. Therefore, the machine doesn't work anymore."
No. I actually know him. You're avoiding the question because it destroys you. So the margin of error for a gyro, margin of error can give you up to 2-degree variance. Margin of error.
Sure.
Why does it always stay the same? How come the margin of error always changes at a different altitude at the same latitude? Wouldn't the margin of error be consistent at all altitudes?
Not necessarily.
Okay, so appeal to.
What if gravity changes with how far you are from the center of the planet?
That doesn't change the speed, the rate of the Earth spinning.
Yes, it changes the speed of time, which I know, the rate of time rather.
But that's not what the gyro doesn't
relativity is saying.
Time.
Altitude does change the diameter slightly, so.
The gyro doesn't detect time. So try again.
I said nothing about time.
Okay, so here's the deal, man. What you're saying that he's lying. The truth is that the gyro, right, a ring laser gyro,
I didn't say he's lying.
It uses the Sagnac effect, okay? It was discovered by a dude named Sagnac. He says it's a vortexual movement in the ether. Now, he was not aware of that at the time. He said, this is interesting. We have 15 degrees. It doesn't look good right now. So then he kept looking into it. He decided to test it further. Actually, a professor told him an idea that you can test to see if it's the vortex of the ether moving or if it's the Earth moving by keeping a certain latitude, but changing altitude. When we did that, it changed over a degree based on the altitude. That debunks that it's because of axial rotation.
So you make up the ether, even though that was disproved. Okay.
You can't respond to my point, man. So we can move on.
You're invoking a magical field to describe how your experiment failed you.
No, I'm not invoking a magical field.
The ether is a magical field.
Falsification is independent of replacement. What I'm saying is you're claiming that it's because of axial rotation, but if you maintain latitude and change altitude, it changes, debunking your claim. I can offer a replacement. I don't have to, but I will go back to the very person that discovered the effect the ring laser gyro is built using, which is called the Sagnac effect. What he said was it was the vortexual movement in the ether. That's all I said. I don't have to replace it. Your claim is wrong. It doesn't prove the Earth is spinning because it changes at different altitudes.
How come he thought it would prove the Earth is spinning before the experiment ran, and he only changed his mind after he failed?
He had to further research it. That's called actual intellectual honesty.
He had to accommodate his failure.
Can I just ask, did Sagnac conclude that the Earth was flat from his inquiry? Because ether model doesn't mean flat Earth. That's two different classes of models.
That's right. But in his opener, he tried to call out Bob and slander him. So I exposed him for not knowing what he was talking about. And I told the true story because I know him personally. And the truth is he went to different altitudes and it debunks the claim of axial rotation. So we can move on now. I just wanted to call out his slander in his opener. So it has nothing to do with if the Earth is flat or not. That's true.
Even though it measured axial rotation both times. Interesting.
It literally didn't though because it changed.
So you can't actually replace the model. One reason is what I already mentioned, is stars. I'm just responding to what you said. You claimed you can replace the model, but that's the reason you won't make a map. because you can't.
I did not claim I could read.
You did. You said I could replace it. I'm not going to, because you
So I can
claim you don't
replace
have to.
the explanation of a gyro.
Okay. Well, my next point is going to be the same. The stars spin in different directions depending on hemisphere, and they just go in a straight line on the equator. So explain that on a flat plane.
Okay, well, first of all, they all go in the same direction. So when you say that they spin in different directions, you're just patently wrong. All stars go east to west. They don't go in a different direction. They all go the same direction. Whenever you look south, you're looking in a different direction. So then you have clockwise and counterclockwise relative to perception, correct?
Yeah, but that can't change no matter how many times you spin around.
No, it changes based on which direction you're viewing it.
No, it doesn't.
Perspective
It
of
changes
the
on
observer.
which hemisphere you're on. You can look in any direction on the northern hemisphere, and it will spin, I think, counterclockwise. And if you look in any direction on the southern hemisphere, it'll spin counterclockwise.
Because it's clockwise and counterclockwise are relative to perception. They all move east to west, though. How is this?
You can't get that spinning effect on a flat Earth.
Well, the sky is spinning, my man. So I guess you need to catch up.
But
We
if
showed
they're
you
spinning-
mainstream physicists telling you that there's no terrestrial observation that proves that the Earth is moving. We even quoted Einstein saying that.
Yeah.
So do you think that means that the Earth is not moving? Just because
I
we
think
can't measure it?
Well, no, I think it's the default position, because to do anything in the real world, whether it be fly planes or helicopters or shoot interballistic missiles or use railguns or anything the military does, or electromagnetic propagation of weapon systems, we have to assume that the Earth is flat, dielectric plane, and that it doesn't move. That's the default position with all practical evidence. You're claiming something antithetical.
Well, that's
to that.
because the technology is being deployed at close range to the surface. Okay,
100 miles.
It's a scales thing. Well,
100 miles?
What's the alleged radius of the planet?
3,959 miles, which would be 6,666 feet at 100 miles. That's a big difference. You'd miss your target by over 6,000 feet.
Yes.
So.
Okay.
So
I've
Same with-
told myself a long time ago I wasn't going to try to do math on shows, but I appreciate the pushback. And
Yeah, it's all good. I mean, but this is the point, the overall arcing point, right? And I know like Kai talks because I don't want to just be like mansplaining, but here's what I'm saying, right? So we had the default position with all evidence. You're making a claim antithetical to that. Now there's a misnomer where in the world everyone thinks flat earthers are so dumb. Oh, you think the Earth is stationary? You're crazy. But the truth, we've proven that the Earth is spinning. But the truth is, even Einstein himself will tell you that you cannot prove the Earth is spinning from the Earth, and that all these physicists will tell you that. But then we have no-name people that appeal to authority, those very authorities, saying that it's been proven from the Earth, which just shows ignorance of the subject. All we're pointing out is that we have the default position. You have the burden of proof if you're claiming something antithetical to that.
well, we have models that make predictions that we can then verify. So
The
Sorry.
live satellite feed from space shows live weather conditions. You can go debunk that anytime if you find any errors in the weather.
You think it's like
Video
live
from space.
24/7? Is that what you think?
Yeah,
No, it's literally not. It has like 10 to 15 minutes in between each shot. You didn't know that?
it's live. You can't Photoshop. I can't even Photoshop a thumbnail in 10 minutes. So
You don't think
you're supposed to
algorithmic?
So you're supposed to Photoshop every piece of weather data from an entire half of the globe every 10 minutes.
The
That's
clouds
what
don't
you're
even
telling
match
me.
half the time. You're just making stuff up.
Then go show me where
We have. Go check out Globebusters.
Sunday.
Show me
Actually,
where
give
the
me a-
water-
can I just
no,
ask, like in your model, if the Earth is stationary, what's moving?
The sky, the
The
stuff
sky.
in the sky. So there's a vortexual movement in the sky, and that's where everything moves. That's why Polaris has stayed the same place forever.
Yeah. And they
But there's
reset.
Everything moves. So that, don't you think that would take a lot of energy?
Yes,
move
it would.
everything.
It would. That's why
The
your
reason
model
why
is
we
insane.
can't tell that we aren't at rest is because the universe abides by minimum energy, not because we're not at rest. We're not because we literally are at rest. We can easily falsify the notion we're actually literally at rest by virtue of the fact that the sun rises and sets. It's just a question of
but-
how do we account for the fact that there's so much stability, but also so much motion. And
just
that is
explained
by
to
the
you that-
same principle that gives us our sensory perception, that we can reliably say, why does it always feel like no matter where I am, I'm at the center of the universe, and the planet feels the same way and everything else? That's the least action principle. And we can use that to build up things like, go ahead.
So what I was going to say is, I believe one of the quotes, I don't know if we included this, but there's no celestial observation that can be done to differentiate whether the Earth is moving or the heavens above are rotating. So I want to know when the academic community established and how they established that the Earth itself is rotating and not the celestial objects in the sky.
Yeah, that's an equivalence principle. So when you want to point to that, there's this indistinguishability of perspectives. We need to use an operating principle that has been meta-analytically established to be the case in many other things, which is the least action principle. So you take your two possibilities and you establish which one would take less energy to get going. But what does it mean to get the system going? What does it mean to energize a system? Where does our planet get its energy from of motion? That's a very hard thing to think about, but go ahead, please.
So you're just talking about a philosophical argument. I'm actually wondering how did they actually prove it? How did they?
They assumed globe spheres, and then they model gravity as an attractive force in that, and it's, I guess, close enough. The three body problem doesn't have a solution. That is an issue.
This is why Jen is an MVP, is because she's intellectually honest. As she said, they assumed globe, but we want to make sure, how do we know the assumption is correct? How do we know that the Earth is actually rotating? And they gave us a speed too, 1,000 miles per hour. So how did they get that amount, that measurement?
Well, she answered it, right? And so I applaud you for that. I applaud you for being honest. And to be fair, to help you out, it doesn't prove one way or the other, right? Like the fact that it was an assumption and that you can model it out, that doesn't prove or disprove it, right? But the point is that it's just an assumption. And you're right that for the Earth to be stationary and everything in the sky move, there would require a field of energy that is immense. But who's to say that's not the case? And Nikola Tesla would say that any attempt to explain the movement of celestial objects without a field of energy is a futile pursuit destined to oblivion. He was just a literal genius. So yeah, there's a field of energy. The sky moves. Polaris doesn't move. To claim otherwise, and you say it's just the least action, it's at rest. We're spinning, revolving around the sun.
It feels like we're at rest. I'm not even at a point of saying what's actually happening. We have to start with what it feels like, because we're building these principles up intuitively and perceptively. So we can all agree that it feels like there's a center to what we're experiencing. It feels like we're in the center of the universe. That's kind of nice. But anyway, that doesn't make it real, is my point.
What could it be real?
We can account for that by saying, well, there's this tendency for the universe to just be like ultra lazy. So even though it has intrinsic motion, it's also ultra lazy with how it dispenses that motion. So you're navigating between two boundary conditions. So what we've done now is look at the evidence. And now we want to say, okay, well, what actually explains this? And it may be a question of, well, what is the most reasonable shape to assume that the planet is? And then we can build a model from that, rather than looking at data to then try to infer what the shape of the planet must be based on data, because any interpretation of data requires what amount to assumptions. So the question is, what's the most reasonable assumption on the get-go to actually build the entire model from?
The only assumptions are always the globe. It's like when we fly a plane, we have to assume the Earth is flat and stationary, but we can assume it's actually curving and spinning, and gravity keeps it perfectly to where it just presents itself flat and stationary. When we shoot a laser and it goes and hits the other target and it's not blocked by over 400 feet that should block it, we can see that clearly the laser hit it, or we can assume that light must have had to have bent right over it and we just can't tell. See, there's only one side that consistently makes reification fallacies and assumptions, and that's kind of our point. We need substantial proof, right? And it doesn't exist. And philosophy is not going to cut it. And that's what the truth is. And you've nailed it on the head. Those will tell you that it's a philosophical discussion and that the geocentric Earth can never be disproven, but we avoid it at all costs because of the horror of a unique position. That is a philosophical bias. That is not science. And if we can at least have that honest distinction made, then we'd be happy to let the chips fall where they may. Make your own decision. But it's not modern times. We're painted as crazy people denying science. No, we're denying philosophy and religion. That's what we're denying.
Mm-hmm.
So did you want to jump in here, Taylor?
Yeah, I want to address the fact that we do shoot lasers to prove that the moon is not in the local atmosphere. At least there is a laser reflector on the moon. Takes longer than it would if it was in the local atmosphere. But the main point was we do not use a flat Earth to calculate flights. They use a globe Earth. That if on a flat Earth, all the flight paths are curved instead of straight. But on a globe Earth, they're straight. So what's up with that? Also, James, if I could share my screen real quick.
So you are, sorry, I just wanted to make Taylor aware that the mainstream says that the moon is in the Earth's atmosphere. Are you aware of
that? Not
they
how
say
you
that.
say.
They recently discovered that.
Not as close as you say. It's only technically the thinnest possible atmosphere, but it is, you could fit all the planets in the solar system in between the Earth and the moon. It's just how big the atmosphere technically is. So you are, again, taking things out of context.
No, you just said it wasn't.
What is that? What's that supposed to establish? Sorry? What does that fact establish?
What I said?
Yeah, it's just unclear what's the point of what you just said.
Because he said something about the moon is not in the atmosphere, and I just wanted him to know that the mainstream says that the moon is in Earth's atmosphere.
Yeah, you're playing with semantics. So it's much farther than you guys claim by leaps and bounds. But what I'm sharing...
how far is the moon?
I'm not sure the exact number, but you can fit all of the planets in the solar system between them.
238,000 miles.
Okay. Do you guys
that's what
believe that?
NASA says.
Yeah.
No, I don't believe pseudoscience, man.
Yeah, you guys think it's much closer, but we can reflect a laser off of it.
So this is the problem, though. If you don't know the medium, then you don't understand what you're perceiving. So it can be perceived to be many things based on the medium. And I don't buy stories of vacuum. That's
well, we do know the medium because we went there and put a reflector on the moon.
You didn't go anywhere, bro.
I'm talking about humans. So
you mean you're talking about NASA?
What I'm putting on the screen is showing the rotation of the stars, the apparent rotation of the stars. It's actually the rotation of the planet, but you know what I mean.
I didn't see
it doesn't matter which direction you face. They're going to be spinning the same clockwise or anti-clockwise fashion. So that's all I wanted to share. I'm sorry if I took up too much screen sharing, but
just recapped what we already discussed.
Hey, I got a question.
No, you didn't. You never addressed the fact that it doesn't matter which direction you face. It matters which part of the globe you're on, which direction they go. And that's a problem for the flat Earth, because then the distance between stars is getting shorter and larger if we're on a flat Earth, but it's not a problem on a globe Earth.
I just wanted to address something that you brought up before about when you're flying a plane, you don't assume a flat Earth. So Witsit is going to pull up a conversation we just had with pilots like a month ago. So also I just wanted to pull up a few things here. So this is aerostudents.com /course/flight dynamics. Okay. So any introductory pilot is going to learn about assumptions that are assumed when they're flying the planes they're flying. The first one is that the plane is assuming there is a flat Earth. The Earth's curve 0. Second is there is a non-rotating Earth. No Coriolis accelerations and such are present. So I can pull up another.
Well, how come you forgot the assumption that the plane is a rigid body, even though we know that the plane is not a rigid body?
You think that's analogous to not accounting for Earth curvature?
Yeah,
just to clarify, I believe 100
plane
because it's negligible.
Because
because
it's simpler math.
It's negligible.
Just to make Taylor aware, because he's probably not aware, so they tell us the radius of the Earth is 3,959 miles, which means there should be an 8-inch drop per mile squared. That number is exponential. So just an idea, so you get some numbers, over 100 miles across the Earth, there should be a 6,660 foot drop. Okay, that's immense. That would absolutely need to be taken into account if you're flying a plane. So
I don't actually think it would, because I just real quick looked it up. It says 7.2 miles is commercial aircraft relative to 3963 radius of Earth, 0.01% difference.
Mm-hmm.
You'd be so close to the surface that it would make total sense to approximate it. Obviously not totally, but close to what would appear to be a plane.
Okay, we're going to play
Negligible.
the pilots. Is it cool if we just play the pilots real fast? Because someone says no flat earthers have ever flight a plane. I know over 10 of them, but here, let's just let's play it real fast. It's just 13 seconds. And so we'll see what the pilots say, if that's cool with you, James.
Ready?
Okay.
Right. Yeah. So basically, it's like the Earth spins and curves, but you fly the plane like it's flat and stationary. Yeah.
Yeah.
So it could be flat and stationary.
Okay.
They weren't ready for that red pill at their lunch break, obviously. But there you have it.
Did
They
you see that
fly
guy's
the-
face? He looked like he was like falling in love with that idea. He was like,
There's so many,
Mhm.
there's tons of videos. They
So-
obviously get shadow banned on YouTube, but there's tons of videos where people just ask the pilots, hey, do you account for curvature or rotation when you're flying the plane? No, man, we fly it.
if
as
you're
it's
flying at
flat.
0.1% of the size of the planet, you wouldn't expect to account for curvature. Can you accept that? It's a very small
What do you say? Gravity's
proportion.
gravity's dipping you down?
No, the idea is that you have a really imagine a sphere that just is super big, okay, and you're an ant on that sphere. You're a teeny tiny little nothing. It's approximately flat when you're on a very small area of it.
Okay, but if I
So-
fly 5,000 miles and I keep just going straight, the Earth's going to be going down beneath me, right? So
No,
I'm
you're
gonna
always going to
have
be at the same approximate distance because you're not going to want to deviate in terms of where you are in gravity because it takes so much energy to overcome gravity. You only want to go as high as you absolutely need to. Okay, so I just looked it up real quick. It says 5.9 to 7.2 miles. Even in a high estimate, that's 0.1% of the radius of the planet.
You want me to tell you
So
what the
if you're
actual
flying-
pilots say? You want me to tell you what they actually say? So they say they maintain altimeter pressure zones. They use altimeter to maintain pressure zones, and they go up and down, and that's what
Right.
they're fluctuating. And he says gravity is actually going to take you around the curve without you noticing it. That's the official explanation.
That's
Correct,
again,
'cause if
that's the
you-
least action principle. That everything is saving energy to the greatest extent, meaning that geodesics happen spontaneously, and a geodesic in flat space is a straight line. But a geodesic on a sphere, the shortest distance between 2 points, that's something called a great circle. So there is some curvature that happens, which can be followed.
Do
But this is
circles
extremely
happen on-
hard
a circle
to
happen on a
visualize.
flat
This I wouldn't start there if I was trying to actually understand what's going on here, because you got to really put yourself in the position like you're an ant on an anthill trying to figure out something that is inconceivably larger than you. So it makes a lot of sense to acknowledge what seems attractive to believe, but also to realize that we weren't built to conceive these things. Doesn't mean we can't eventually get to the right answer, but we should be very cautious and skeptical. And
That
So
excuse
if you
doesn't
start-
work, though, because the radius is a certain size. If I'm 1 foot off the Earth, I would see the curve of the Earth just 1 mile away. So it's not just too big to see. I would see it 1 mile away.
If you start flying off of the Earth in a straight line, eventually you're going to be going basically straight upward. So you're
Into
going to
outer
have
space.
to actually be adjusting to maintain a straight upward position. You don't need to adjust.
You mean it has to conform with the ball. It wouldn't be going up. You would have to actually be dipping
No,
the
you don't
nose
ha-
down to
you would
conform
have
with the
to-
curve of the Earth.
You would have to adjust and try to go straight up if you were flying off of the curve of the Earth. You don't have to make any adjustments to maintain a level position because the forces automatically align, drag and just the aerodynamics of the plane will always put it level. You would have to increase the engines in order to keep going at a steeper and steeper angle.
Okay, your answer is gravity pulls the plane around the ball. If you don't want to absorb it, I don't care. That's objectively what it is. But here's my
I
question. Here's my
actually
So we
said
fly the
aerodynamics.
plane- We fly
So
the plane
listen.
like we fly the plane like the Earth is flat and stationary. So could it be flat and stationary?
no,
So it would be different. We'd have to fly planes different on a flat and stationary Earth.
It
Well,
would be
address-
impossible based on what physics we observe for it to be flat and stationary. It would violate gravity, which is something we can
Gravity was made
verify.
to explain. Gravity was made to explain the Earth being a ball, though. So that's so backwards. We came up with gravity to explain omnidirectionality on a ball. That's why we proposed gravity. Then we're still trying to figure it out. We've never discovered the graviton. The theory of relativity doesn't work when we apply it to the universe. It's off by 95% with dark matter and dark energy. We have numerous problems. Quantum mechanics has completely dismantled relativistic applications. And Newtonian physics had to be thrown away 100 years ago. We keep gravity because it has to exist for the Earth to be a ball. No. We don't know the Earth's a ball because of gravity. We know gravity exists because the Earth's a ball. That's called a begging the question fallacy.
I have some more documents I
thing-
would like to read. I just have some more documents I would like to read that again reiterate the same thing. This one is from www.faa.gov. The engineering analysis and design of the aircraft dynamics model for the FAA. Okay. It says on page 32, the observant reader will notice that the aircraft equations of motion were calculated assuming a flat Earth. I have another article here. This is from nasa.gov/API/citations, a mathematical model for the CH-53 helicopter. The helicopter equations of motion are given in a body axis with respect to a flat, non-rotating Earth. I have so many of these documents, by the way. This goes on. There's like over 100. So for you to say that they are assuming, and we have the video of the pilots, they absolutely do not account for a globe or a moving surface. They're flying over a flat and stationary plane. It's not even able to be argued at this point. You can say no, but you have not provided.
The math is calculated as flat because it's easier, because it's negligible, because the up and down direction, what is that, pitch and yaw or something, is corrects itself. You don't have to pilot the plane to dip down.
Okay,
let's move on to the thing you ignored, which is the flight paths, which are mapped on a globe.
There are numerous flight paths that debunk the globe, though. So that's a
No,
very
there
bad
aren't.
argument. for you to
Emergency flight landings where people were dying or giving birth, they had to land, and they landed in a place that would not fit on a globe.
Also, we would take tons of
It wouldn't
paths that we
fit on a
don't
globe?
take. We would take tons of paths that we don't take on a globe. There's direct shots across a globe that we never take. But when we look at the flat Earth map, it makes perfect sense. And we are not claiming the flat Earth map is perfect because we don't listen carefully, because you love to bring up how we don't have a map and somehow that makes the Earth a ball, right? This is why I tell you falsification is independent of replacement. The reason we can't make a map is because we don't have an accurate central point to start the Cartesian coordinate system. So it's impossible without an accurate central point. It's illegal to go within 500 miles of each direction of the North Pole. So that's the problem. So for all the globers out there that love to talk about the map over and over, it's an impossible task because we don't have access to the central point to map it out.
No, it's not. You might have to file some paperwork, but it's not illegal. So
it has to be
you
approved.
claimed that there were locations on the Earth that don't exist on a globe.
What?
No, I said that
emergency flights.
the
So
emergency
the plane
flight
turned.
No, they landed in, I believe, I can't remember specifically. One of them had to do with Alaska, but where they landed did not make any sense on a globe. It would have been far out of the way. Okay. Another flight that people observe that's very suspicious is there should be a direct flight from, for example, Buenos Aires, Argentina to Johannesburg, South Africa. Okay. That would just be the tip of South America to the tip of Africa. In order to get a flight, the best flight that you can get, the fastest one, you have to stop all the way in the Netherlands. Okay. It's not a direct one. That would be a great example of the globe. But on a flat map, that works perfectly.
Do you want us to share the screen and show you that flight path, or?
Sure, because I got a flight path to share with you as well.
Cool. We have all kinds of
There's
them
a
that
flight path that goes right past that.
We're about to show you the actual flight paths, my man. And so I don't understand why Globers bring this up. It's really weird. It's really
Because
weird.
it debunks the flat Earth.
It doesn't, though. It doesn't. That's what I'm trying to explain to you, my man. Flight paths don't help you. I promise.
Well, I
bro.
don't think we ever got.
Oh, I can't hear you.
Jen, we lost
muted.
you, if you can hear me.
You're muted,
Jen. Can
Sorry.
you hear us?
It happened again.
Okay, no worries.
I'm so sorry about that. Tech, boomer tech here. I agreed with you that it ought to look flat if you're sufficiently close to the surface. So did that point get made? Did you understand that? It makes sense to model it as flat, even if it's a sphere?
Yeah, it just happens to work out perfectly. That's the answer. Gravity makes it work out. Gravity accounts for the curvature that you would have to account for. That's the actual answer. We know the answer.
You're basically staying at the same level of the gravity field, because that's the minimum energy solution, is to deviate minimally from a stable gravity field. So if you can get into a point where you're between two pressure gradients and you're sort of sandwiched between them, you just ride that and it remains stable approximately if you're at a same distance from a globe.
Well, you have to go up and down, actually. So actually, you don't just maintain the same. You have to go up and down. We have a 13-minute conversation with pilots explaining it in depth. And our point is, it's just to address the misnomers. It's like they say, if you Google it, you can see the curve of the Earth from a plane. No, you can't. I just now asked 2 pilots right after our plane landed, do you see curvature up there? No, of course not. So it's flat up there. Yeah, of course. They don't even hesitate. Anyone that's actually flown a plane, I used to work at an airport, I know many of them, everyone knows that the Earth looks flat in a plane. Everyone knows you fly the plane like it is flat, and everyone knows you fly the plane like the Earth isn't moving. You can say, well, yeah, it just appears that way. The equivalence principle, relativity, it makes it look that way. Gravity makes it
makes it look that way because of the relative size, okay? You are 0.1% of the size of the total planet off the surface. So the amount of area that you're capable of seeing relative to the total surface is quite small.
Okay, so Google's definitely wrong when it says you can see the curve of the Earth from a plane then, right?
Well, that's unclear exactly what that means, so let's just put that to the side. But I'll grant you that when you're in a plane, it can definitely look like what you're looking down at is flat. However, if I was going to agree with you and say, yeah, the Earth is flat, what I would expect to see under that model is I could look out and see all the way to the other end of the Earth. And so it's a question of, well, why can't I see that? Why does it disappear so predictably at that same point, give or take atmospheric fluctuation?
Yeah, well, the horizon always moves because it's not physical. And in your model, it is physical. But here's a flight path right here from Santiago to Johannesburg. I'm share the screen. So right here, you see on a flat Earth, it's a straight direct path. On the globe Earth, you go up out of your way and then come back down. You could fly straight across the South Atlantic Ocean, but no, you go hundreds of miles out of your way and come back down. There are probably 30 of these flights, though, which is why I don't understand why Globers bring it up. So is there a rebuttal? Why does it work perfect on the flat Earth, but the Earth's a globe, so we added hundreds of unnecessary miles to go out of our way? Is there a rebuttal?
Yeah, so I have my own flight path to share.
So no rebuttal.
To address this one, they might just not book flights there. So you have all these private companies that know that the Earth is flat. You have thousands of employees that are plotting these flight paths, and they know the Earth is flat. Globally, every single company without fail, and they all say the Earth is flat or the Earth is a globe.
So you're not rebutting the actual.
That's just interesting.
So you don't know.
And no, so they might not just go to Johannesburg because of, again, these are private companies. They want to make a profit. So maybe there are more flights to the north of Africa than the south of Africa.
So there
are plenty of explanations.
Gotcha. So we can just make up stuff. Gotcha.
It's hard to know what this evidence is actually saying.
Yeah,
they have to fly that far because that's the most direct path on a flat Earth. They have to fly that way. Mm-hmm. That's why they do it. It's not because, there's probably a reason. No, the reason is that's the only way you can go there. That's the reason. That's why there's not one flight that exists that goes from Santiago to Johannesburg over the South Atlantic Ocean. It goes up and comes down because on a flat Earth, that's the direct path. That's why they do that. You think that private companies that spend money on fuel, their entire business plan is fuel cost effective?
Yeah, that's actually why they shut down the South Pole flights, is because they weren't cost effective. They used to fly them, and they don't anymore. And this just appears to be an economically viable route, because there would be presumably people that wanted to go from Dakar to Johannesburg. So I don't know. This isn't very compelling.
Okay.
Well,
he brought
there
up
is.
flight
It's just
path.
not economically viable. I mean, it's not even clear what a direct path means, right? So you got to be really clear as to what, because we're not even agreeing as to like what if we don't agree on the shape
By
and
the
a direct
way-
path, we're not talking about the same thing.
And all of the continents there are completely distorted. You couldn't, you know that the shorelines are not like that, which is why no flat Earth map ever makes sense.
On the mainstream Mercator map,
So-
it's completely off. They show that Alaska is so tiny and it's like huge. This
So
happens
these
all
are-
the time.
These are direct flight paths, so no stopovers, no the variable of economic, whatever gains that you would get from going to one particular location over another is eliminated. So we have a flight path from Sydney to Santiago, Chile, and New York to London, 5 times the distance in less than twice the time. So why would companies do that? Why would they waste
Yeah,
fuel?
So the fastest air current
And that's
is
also impossible. So that's
the fastest,
another way.
The fastest air currents are literally right there where you drew your little dotted line. You would catch a air current over the Earth. Secondly, you actually have to apply a scale to the southern portion of the map. Did you know that? So that's not, you don't just look at it and say, I think that looks too far. You realize that you actually have to properly apply the scale. So credit to Professor Dave to not know how to use scales. So
That's
okay.
what happens if you flatten the Earth. The scale is off. The southern hemisphere is distorted. That's why a flight that takes 12 and a half hours is 5 times longer than a flight that takes 8 hours. And if wind is a factor here, it would have to be record-breaking hurricanes, 250 miles per hour.
Well, then why does the plane take so much longer when it goes back the other direction against the current? If it has nothing to do with it.
It's not much longer.
It is actually sometimes up to 2 and 3
it's not
hours.
as long as you
2 to
want to
3
say.
hours. 2 to 3 hours.
Yeah. So that's not going to speed up 5 times.
5 times. Well, we don't need
The
5
distance
times.
is over 5 times as long.
No, that's what I'm trying to say.
Preferred
You
direction
are
for the
wrong
trade winds is
because-
actually what you'd expect on a globe, though.
I'm trying to explain to you guys
Rotating
that you guys
globe
are
is constantly getting a different edge of the sun, and so there's a preferred direction for the trade winds to
You guys
blow
didn't
in.
watch. You guys didn't watch the intro where I explained that actually all the currents work better on the flat Earth and showed you how you can actually map them out. But here's the point here. So you're lying and saying it's a certain distance because you're listening to the goofball Professor Dave, and a lot of globe earthers do this. But you have to understand you have to apply a scale to the southern hemisphere.
Explain
That's
that.
how the map works.
How would you fix the scale of the southern hemisphere? Distort Africa immensely so that Australia and South America are closer?
So are you saying you don't know how to read azimuthal maps? Is that what you're telling us? Because that's
don't know how to read them.
Yeah, you have to apply a scale past the equator. It's just like duh. Like you guys use memes. You guys use memes
on a globe.
You don't
You
use
do.
scale.
Not if,
you guys
if it's
use-
actually flat, then that's going to be the distance. Otherwise,
You
you're
guys-
going to have
no.
weird spatial distortions, which again, I guess you'd have to invoke some kind of magic field where there's spatial compression where you can travel further in less time.
This is what you still don't understand. So your meme is a straw man because you didn't apply the scale. Now, that does not mean that's what the Earth has to look like because the Southern Ocean is basically unexplored and we don't actually know what's there. I don't know if you're aware of that, but basically no one goes in the Southern Ocean and we don't know the central point to map out the proportionate layout of the land. You have straw manned even the map. You've shown a basic misunderstanding of how to use maps.
The azimuthal projection fits on a globe. Because if you apply the scale between Santiago and Sydney, then you can do that. But then there's going to be gaps somewhere between the edge of the globe, of the projection of the globe.
There are gonna be gaps. Yeah, there are gonna be areas that aren't mapped out accurately, which is convenient because no one goes to the Southern Ocean. And I also explained to you, you just drew a path.
Okay.
I've objectively debunked you 3 different ways. I'm not going to talk about it for like an hour. Listen.
You're now trying to debunk me with continents you're claiming that you haven't discovered yet.
You go on that little dotted line of yours, and that's going with the currents. When you go the other way, the flight takes at least 3 hours longer. And then to tag on to that, this flight basically never happens. We actually wanted to go try to do it, and you can't find a one-way. You guys just like to draw lines on maps and make up stories. This is a very rare flight if it ever happens, and it's much slower the other way, proving that the reason that the plane goes faster is it rides the air current. It's just objective. So we can move on.
How does that prove? How does that establish a flat Earth?
He's saying it debunks the flat Earth. I just now refuted his claim. I didn't make any claim about it proving a flat Earth. I'm making a point that it doesn't prove a globe Earth. Right. So we can move on now because we refuted that claim. Yeah, go ahead. She's got another point.
Oh, I just thought we'd talk about entropy maybe, since we have the Church of Entropy here.
Yeah, well, entropy is basically just another way of saying the least action principle. So entropy is saying that energy is constantly diffused. That's what entropy says. So there's two ends of it. Okay, one end is we observe a tremendous amount of motion, and the other end is it appears that for a lot of our perceptions and observations, things are at rest. So we have to go in between those two boundary conditions and determine what assumptions we need to make to construct a model, how many assumptions we actually need, and in what order we ought to express the assumptions geometrically or algebraically in order to generate reasonable predictions that we can then look up in the sky and say, oh, our model, it's lining up in the sense that it's telling us maybe something like a future eclipse. Entropy doesn't apply per se to cosmology. Entropy is more about life because it's more about thermodynamics. Whereas in cosmology, it's more about what you might call a stasis field. So something that's moving, we can establish that there's movement going on. You can look at the time lapse going across the sky and establish that there's some type of movement, but there's also a perceptually a tremendous amount of stillness. And we have to account simultaneously for both of those effects if we're going to have a satisfactory model, because clearly these other models aren't quite convincing enough in the sense that this debate is still happening. So I do appreciate having a chance to go through these arguments. I'm ready to go to the questions. I don't know how everyone else is feeling, but I hope we got a lot of the arguments out.
Okay, what she's trying to say is entropy will always increase, and your name is convenient because the second law would refute your claim that there's a pressurized system adjacent to a near perfect vacuum of 10 to the negative 17 torr, because the pressure would obviously seek its equilibrium due to the second law. And natural laws apply to your cosmological claims as well because they make claims about the natural world.
Yeah, I was just going to cover within that movement. Would you agree that high pressure goes to low pressure?
Not necessarily, because pressure is defined relative to a container, and you're not always dealing with a clearly outlined container. And that's where mechanics is really complicated, is when you can't actually conclusively say where it makes sense to claim that there's a boundary, because there is no actual boundary, but there are pseudo boundaries and a conservation in some sense of pseudo boundaries that you can use as a modeling template. But again, this is sort of beyond the scope of what we want to talk about here right now.
This is why I wanted to talk about gravity, is because gravity can act as a container for air. And it doesn't matter if it's electromagnetic or not. All it matters is if air particles are pulled toward other masses.
Gravity has a singular vector of down relative to the center of mass, and gaseous surfaces and omnidirectional infinite vectors. So a singular vector down to the relative center of mass would never in any way contain it. That's why it doesn't contain it at the surface where gravity is the strongest.
I know your word salad is a lot, but
word salad means things don't make sense, but that made sense.
It doesn't make any sense. Air doesn't just move omnidirectionally just because. Air pushes against, what was that?
2-minute warning. We're going to go into Q&A in 2 minutes.
Okay. Air doesn't just just go in different directions. Air will press against other air, so it can move in an upward direction, but gravity will pull that air back down, and it will push against other air, until it balances the force of gravity.
You have a vacuum chamber and you open up the vacuum chamber. What happens to the air surrounding the vacuum chamber?
Surrounding the vacuum chamber.
You have a vacuum chamber and you open the little latch.
Yeah.
Okay.
It goes.
What happens to the air outside the vacuum chamber? What will happen?
It pushes into the vacuum.
It rushes into the vacuum because entropy.
Because of air pressure.
High pressure goes to low pressure.
Why?
So if you have this vacuum up in the room and then there's gas below it, and then you opened up the vacuum, would the gas pressure still go up into the vacuum despite gravity being there?
Yes, because it's being pushed by the other air molecules.
Okay, thanks for playing.
Yeah.
We can't extrapolate this metaphor to the scale of the planet, because what you're talking about is a clear boundary. It's something that was vacuum sealed. And you opened it and pressure you calibrated. You can't then analogize that to the cosmos because there's no clear boundary. And go ahead.
When
Dale.
you look at the scale
in
of
the
the Earth,
academic world that you could have gas pressure without containment, and they cannot
can.
show this.
You
It's in the
can.
definition
You
of
have to
gas
prove
pressure.
gravity also.
It's in the definition. Chemistry.elmhurst.edu. Gas
There
pressure
is-
is the collision of gas molecules against the container,
no,
the physical container.
it's also pressure
No?
against other air molecules. So the
Yeah,
reason
exactly.
air pushes into a vacuum is because the air molecules are hitting each other, pushing them in, and there's no air in the vacuum to stop them from getting pushed. So
Pushing them to what?
Without using
there is pressure differentials. If you're talking about the scale of the Earth, if you're talking about the scale of a propane tank, that's not the scale of the Earth. There is pressure differentials when you go up a mountain. So the further up you go, there's not air pressing down on the air at the top of a mountain, not as much relatively at the bottom, because it's lower pressure. The thing that's keeping the thing that's pushing the air down is gravity at the top of the mountain.
What we have
That
to do
makes
is
it
go
feel
into Q&A. Want to remind you, if you want to hear more from either side, folks, you can click on the links below. You can hear more about the views from either side, as we really do appreciate our guests. And we have to say, my dear friends, if you haven't yet, hit share, as that really does help us get the word out. If you think that you have a friend who you're like, oh, they'd enjoy this debate, now's a great opportunity to hit that share button below, and you can share it with them, enjoy it together, and like I said, it helps Modern Day Debate have a positive influence as we strive to be a neutral and fair platform for everybody. So with that, we're going to jump into the Q&A. Thanks very much for your first question. This one coming in from Joe Schwartz. Says, can we all agree that regardless of shape, the Earth is pretty dope? Thanks for that, Joe.
Yeah, the Earth is super dope.
And thanks for your super sticker from Steven. Appreciate your support. As well as Dr. Anarchy, who says, hey, Witsit, when Blue Origin or SpaceX starts to offer commercial seats on a spacecraft to orbit the globe, would you be willing to take a trip and admit that you have been wrong all this time?
Well, if it's just 4 minutes of weightlessness, which is identical to a vomit comment, I probably wouldn't admit I'm wrong. They'd have to let me independently verify it and document it. I also know there's something called a circumference of light. Divergent rays create a circumference of light. You could go up on a flat surface and appear to have a slight curve due to circumference of light. So no, I probably still wouldn't believe it. I know you guys don't like that. If they took me out into space and I could float around and see that the Earth was a ball from the outside, then yes, I'd believe it, and that'll never happen.
This one coming in from Do Appreciate Your Question. Will Stewart says, Jen wins, doesn't matter what she says. As well as, you got a fan out there, Jen. He says there are many variables that can explain different testimony about what can be seen. The visor technology, polarized versus not, light refraction, etc. Are you considering this when claiming contradiction?
Well, was that question was for us? I must have not followed the question there. I'm not sure.
I think it was. They said there are many variables that can explain different testimony about what can be seen. The visor technology, polarized versus not, light refraction, etc. Are you considering this when claiming that there's a contradiction?
Yeah, that doesn't work when the same person contradicts their own testimony from the same occurrence and experience.
This one coming in from Sean Hawkins says, I'm still waiting to see Kai zoom the sun back in after it sets. I think this might have been regarding one of your earlier pictures or videos. Says, so
Oh, yeah.
I'll repeat it. They said, I'm still waiting to see Kai zoom the sun back in after it sets. If she can't, she has no choice but to concede to curvature.
Okay. Hello, my obsessive fan. There's videos on YouTube, but also once the sun disappears because of perspective, so once it's actually disappeared beyond the vanishing point, then you obviously can't bring it back. So, but there is no curve. It's simply perspective.
You got it. This one coming in from Kango44 says, it's very, 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 very easy to measure the shape of the Earth. Humans did it 2,500 years ago. I did it last week myself. It's a globe. Also, buy a telescope. Then you can see what the planets look like.
Okay, look through a telescope probably 20 times, so save it. Obviously, putting sticks in the ground is not a measurement. You have reverse engineered a calculation. The calculations are not measurement. Of course, it works the same on a flat Earth.
Yes.
So why do you have to bring up something from 2,500 years ago? If we have NASA getting $60 million a day, it seems kind of weird. Can we get physical measurement, not presumptive calculation?
Calculations are relationships between measurements.
Yeah, its calculations are synonymous with measurements, though.
What did I just say?
I'm asking, are they the same?
No.
So you have to have physical measurement first, right?
That's what the sticks are measuring, yeah.
Then what are they? What are they?
Calculations or
Calculate the
interpretations
relationship
on
between
measurements. That's right.
What are the sticks measuring?
Angle of the sun's rays.
Well, and the shadows actually. But if I do that same thing on a flat table, I can map it out with calculations to make the table a sphere. Did you not know that?
You can't, but you know.
Okay.
It also presupposes a distant sun,
Yeah.
which they had no way of establishing.
And assumes no
It's-
refraction.
Yeah, you're ignoring the time factor, but that's cool.
No. Yeah, we're pointing out the time factor and how stupid the claim is for Globers to regurgitate what Google told them that it was proven 2,500 years ago. It's ridiculous. Grow up.
It's not Google, it's the navigators.
There's no primary documentation of this actual occurrence. Did you know that?
I've got to move to the next one. This one coming in from Kango44 says, showing the planets through a P900 and saying, quote, look, the planets are wandering stars, unquote, is the very height of dishonesty. Anyone can produce very clear images of the planets with a cheap telescope.
It's so funny because the definition of planea was wandering star in the past.
Yeah, and actually, when you look at them through telescopes, they pulsate. You'll never actually make a static observation of the lights, which is the entire point. And actually, there seems to be an analog and digital difference, which is why the P900 catches the cymatic patterns.
This one coming in from Balthazar228 says, do either of the flat earthers agree with Alden's theory of level Earth?
Not familiar.
Gotcha. That's it. They're just trolling you. I just wanted to see what you'd say, though. Okay, this one coming in from, it's one of Vosh's memes. But Will Stewart says, there are many variables that can explain different testimony about... Oh, we got that one. Sorry about that. Ilabaka, thanks for your question, says, Witsit, why hasn't Bob published or repeated his gyro test at different elevations? If that's true, he'll get fame and a Nobel Prize. What is he waiting for?
He does have the documentation. Why is he not published it? I don't know. You'd have to ask him. Actually, the reason he didn't publish it, the real answer, I guess he's cool with me saying this, is because he gave it to be an exclusive in the Flatlanders episode that hasn't come out yet. And so he was trying to do them a favor for letting them exclusively release it. And then secondly, he will never get a Nobel Prize because it's not about being honest or having new innovation or any type of discovery. It's about fitting the status quo of consensus. And you'll just get hand-wave dismissal like we got from Taylor earlier, where he's like, no, margin of error.
You're a liar.
Margin of error. So that doesn't it doesn't really matter, to be honest. But
Didn't
there's your answer.
Didn't you just go on and on about how Einstein overturned paradigm of physics? So that contradicts what you just said.
No, because it still fit within the consensus. Actually, that was thanks for making my point, which was Michelson Morley debunked the fact that the Earth was supposedly spinning. So theory of relativity had to come in and throw their little cape on to save the heliocentric model I was talking. And so then it was once again fitting into consensus, which was my point. So we can move on.
This one coming in from Do Appreciate It. Doofus Manfred says Bob released the full data from his FO gyro. The different rates detected corresponded directly to the fog being at temperatures out of spec. Hashtag GLTF.
Okay, try to not use so many acronyms. We're not 7th graders. And I don't know what you're talking about. He hasn't released the full data. He gave it to them exclusively. So I think you might have made that up.
This one coming in from, do appreciate your question. Will Stewart strikes again, says you claim contradiction. But what about, did he do that one twice? No. It's a very close to one that we were at earlier, but it's a different one. He says, you claim contradiction, but what about variables in visor technology, refraction, position, etc.? That isn't A and not A at the same time and in the same sense. Have you considered this?
Yeah. Again, it doesn't work if it's the same person talking about their own experience, but then giving contradictory testimony. Just like in court, they would be considered an invalid witness.
Yes.
You got it. This one coming in from, do appreciate your question. Tim Pryor says, they say particles of the atmosphere reach to the moon. Not that it's in the atmosphere. Read the whole article.
How can particles of the atmosphere go out past the moon without the atmosphere being out past the moon?
This one from Robert Summers. Well, hold on, just to be sure I read it right. They say particles of the atmosphere reach to the moon, not that it's in the atmosphere.
Well, it's a question of like the gradient falling off. It's a bit of a Theseus's ship. Like, how dense does the atmosphere have to be before it's not the atmosphere anymore? It's arbitrary in the sense that, there might be a particle from the planet that's on Mars right now, but we don't count it as part of the atmosphere, do we?
How many
so we have
drops
no
of
idea
rain
where
till
the
it's
atmosphere
raining?
ends. Got it. We have no idea where the atmosphere ends. Got it.
This one coming in from, do appreciate your question.
The gradient.
Robert Summers.
Gradient, but you have to have pressure to have a gradient, by the way, honey.
Robert Summers says,
There is a pressure gradient. You can measure it.
regarding gyro, even if the values did change outside of a margin of error, what was being measured then?
That was for him, I would imagine. It was for me? What's the question? It's got to be for him, right? If it's outside the margin of error.
He said even.
No, I think it's the gyro experiment.
Gyro.
Right, he's the one that claimed it was he's the one that claimed it was margin of error. So
He's asking if it's outside the margin of error.
They say even if the values did change outside of a margin of error, what was being measured then?
Yeah. The change in the vortexual movement within the ether. So if you had a tornado, it's wider at the top and it's smaller and tighter at the bottom. So you're measuring a differential of movement based on the vortexual motion. So it would change with altitude at the same latitude. On the globe, it would stay exactly the same at the same latitude.
This one coming in from, do appreciate it, Will Stewart. Oh, he's hungry. He says, if you maintain 30,000 feet round or flat, you fly at 30,000 feet. Whether the earth is round or flat. Round, you stay at 30,000 feet. Flat, you stay at 30,000 feet. It's not flying perpendicular. Explain.
Yeah. Okay. So the difference is on a globe, to maintain 30,000 relative to level, you have to actually be going down as opposed to just maintaining over top of a horizontal, which is what we actually assume it to be, as well as sea level to get your altitude in the first place.
This one coming in from Nuclear Creation says, so if we are living on a flat earth, can we fall off of it? And since we supposedly live on the flat part, then what the F is on the other side? And are other stars and planets also flat?
Oh, so the word other would insinuate that you're begging the question that we are a planet. So they are something different than the Earth. They move top of the Earth, create a sky clock. What's below it? Well, that's why you've always heard as above, so below. It's a hermetic principle. It tracks back forever. It's because, like I showed you with the magnetic field, we're the inertial plane. So we have the same top of the magnetic field toroid underneath it as well. And that's the only way that it could exist. And when people smirk and laugh about it, it's really funny because Harvard still admits they can't explain the magnetic field in the globe, and I can explain it perfectly. So the answer is that you're within the the inertial plane. There's the same above, same below. And no, we aren't planets. And no, you can't fall off of the edge with your trifecta question there. That's a ridiculous idea.
We're contained.
Can you fall off of a shoreline? Secondly, because we measure the Earth to be a plane, we're not claiming the entirety of it or a shape. It could be some type of realm. We have no idea. It doesn't matter. It's illegal to go there.
And we're contained. That's why we have gas pressure. And from there, then you would get a gradient.
So you can't fall off through a container, can you?
This one coming in from
alchemy, huh?
Do appreciate it. High Flyer says, I've flown 22 years as a U.S. Air Force U-2 pilot above 70,000 feet. Every time I've looked outside, the Earth was curved.
Okay, so I want you to really listen carefully to this. There's something called the circumference of light based on Rayleigh scattering within the air, okay? So divergent rays have a circumference of light. Now you can use AutoCAD or whatever to explain this to you. If you go up over a flat surface, the circumference of light based on certain altitudes will actually give the illusion of a slight curve. Of course, it doesn't actually match the globe predictions, but secondly, you can't see the actual curvature of the globe from 70,000 feet according to your own math.
And Neil deGrasse Tyson,
which says 62 miles, you can't see it. So it's really, I'm not even saying you're lying. Because of the circumference of light over a flat Earth, it's possible that you could perceive that, certainly if you really want to believe it, because that is what happens with Rayleigh scattering and a circumference of light. But you wouldn't see the physical curvature according to your own model.
Got it. This one coming in from Do Appreciate It. Isla Baca says, Witsit, you know when there were direct Chile to San Antonio flights. SA might also be
San Antonio and whatever it's called. And what is it? I forgot to say it now. And what is it called? Do you want to? Somebody here knows. I forgot.
Saudi Arabia? Well, they say
no. It's like Antagio. I just don't know how to pronounce it. It's like A-N-T-I-G-O. Something like that.
They say, Witsit, you know when there were direct Chile to SA flights, World Cup in Santiago charters, many of them. Why? Because it's profitable. Other times, not so much.
Yeah, basically never happens. And again, it doesn't explain anything because you're following the jet streams. You're literally going over top of the air current. That's why when you go back the other way, it's significantly slower. Makes no sense on a globe, though.
Gotcha. Might have Ilabaka corrected me. South Africa, but nonetheless, I think the same point is. My guess is your answer is the same either way. But thanks for clarifying that, Ilabaka. And then Nuclear Creation says, would love for flat earthers in debate to respond. I don't know if they mean to themselves or to the other speakers. I don't know. But anyway, Dan the Machine, or maybe it's to their previous question. Dan the Machine says, how do you have a quote-unquote southern hemisphere on a flat earth? Is it circumference? If so, what's west and what's east?
So that's why when I said hemisphere, I air quoted it. East to west is relative to center. We travel using a compass, which is north, which points to the center. You go east and west. That's why you can circumnavigate on both a globe and a flat earth. It is not mutually exclusive in any way. East and west is the same relative to north.
Gotcha. And thank you very much for this question coming in from 2 seconds. As I mentioned, our guests are linked in the description, folks. That includes if you're listening via the podcast. And Javid Benskazmi, thanks for your question, says for Witsit and Kai, just saw Shi Lin on Jake's stream. She believes the biblical map is flat, square map with North Pole in the north edge, not the center, and South Pole in the south edge. Would this map be considered?
I'd have to see it and look out the specifics. Like, to be honest, it's very open right now. And anyone that's an honest researcher and looks into this knows that we don't know the accurate layout of the land, and only people that have a bias are going to say otherwise. So I would be interested to see any and all projections. It's worth looking at.
This one from Robert Summer says, wait, Witsit, are you asserting they wouldn't allow you to become an astronaut?
You have to be a Freemason.
Yeah, I'm not big into drinking baby blood or being like Freemason, dress up in the dark, playing like dress up with grown adults. So maybe not.
This one coming in from, do appreciate your question. Whiskey. Whiskey Brandt says, why haven't you guys presented one globe proof? I think that's for you, Jen and Taylor.
Yeah, we have. So when did you
I
stop
didn't-
beating your
I'm
wife?
sorry,
I
go
don't
ahead.
know.
I didn't want to go down the same road as always, just presenting the same exact arguments. I think we made a pretty strong case, but a proof really depends on your standards of proof. And Taylor said it best, if you're going to be skeptical, sort of behooves you to be uniformly skeptical. And it's clear that there's a level of skepticism being applied to the globe, even though the evidence does clearly support it, properly interpreted, that's just not being applied to the alternative hypothesis, which sadly doesn't appear to be specific enough to really mount to what might be necessary to a proof of disproving the opponent's position.
You got it. This one from
Sorry, good.
Ron Tronimus says, actual alleged outer space is pitch black. There are no stars in space. Explain, Taylor and Jen.
What was it again?
They said actual alleged outer space is pitch black. There are no stars in space. Now explain, Taylor and Jen.
I really want to take this one if it's okay, because let's not say that we can't establish that there are no stars. Maybe the testimony of some of these astronauts went up and they said it was very dark, but let's think about what's going on here. We just had some experiments show us that the atmosphere is really big. What is that doing? It's a lens. What does a lens do? Focuses light. That's why you get the twinkles and all those super fun, beautiful, spiritual geometry, what have you effects. That's all the combined effects of the water in the atmosphere, which is what makes this such a great model for that, because it's got a tremendous amount of conservation of structure, even though it's quite wonky.
Taylor, anything?
Yeah, I mean, if you don't accept picture evidence of stars in the sky, but you accept picture evidence of the Earth being flat, even though the laws of perspective don't work for flat Earth, they only work, they only fit a globe model, et cetera, et cetera. I mean, it's the double standard of evidence again.
Can we get a measurement of Earth?
I don't know what
curvature,
else. We can't send everyone to space yet, so I don't know what else you want other than pictures.
Can't send
Physical
anyone to
measurement
space.
of Earth curvature, probably.
Yeah, or just prove that you can have gas pressure without a container.
But we'll move on. We don't want to. That
Yeah,
was your
sorry.
question. It's all good.
This one coming in from, do
That's
appreciate
easy.
it. Kana Bear, let me know if I pronounced it right, says boats don't fall over the edge of an imaginary sphere horizon. We see way further. The globe model was made using flat Earth elevation angle measurements. Taylor.
The globe was measured with what?
They said the globe model was made using flat Earth elevation angle measurements.
No. I don't know.
I'm
The
not
globe
for
was
sure
a
who this
lot
is
of
for.
different things. Partially, originally sea navigation. They couldn't make flat maps work. So
This one from let me know if I did get that Kana Bear, if I got that right in terms of understanding it and reading it. Ela Baca, thanks for your question, says, Witsit, if we find a grain of sand 1 mile from the beach, does that mean the beach goes that far? Analog to the atmosphere.
I don't understand.
I'll read it one more
So
time.
That sounds like a. Okay.
basically the question is how many grains of sand is a beach? So if you have a couple pieces of sand from the beach scattered on the road, does the beach reach to the road, or is that just a piece of the beach that's on the road?
Oh, we're talking about the atmosphere. Oh, okay. Oh, you're saying analogous to the atmosphere. I get it now. Yeah. If there's a magical vacuum sitting next to an atmosphere, even though gases have no intrinsic shape and that's stupid, then the gas that keeps going out would still technically be part of the atmosphere. At what point in time do you draw the line? You don't have a road or anything like that. That's
At the
not a
moon. At the
right
moon.
at the moon. That's where it
You
stops.
draw.
right there at the
You can approximate it at the moon because the moon is what's binding. I mean, you're asking a great question. The moon is what's binding the atmosphere. I don't think this is very well understood, but it would boil off if it weren't for the moon constantly scooping it back in. So this is a very good question. That doesn't.
I like that you
disprove
at least.
slow
I
birth.
do really like you, Jen, in the sense that you're willing to think outside of what they tell you that we know everything about. So, like, I will give you that. I think that's beautiful, and that's what everyone needs to do, regardless of what they think about this subject.
This one coming in
And
from.
I don't think there's anything ridiculous about having a gradient. We can observe
Yeah, me
those
either.
all
The only way you
time.
can have a great. But listen, man. The reason you have a gradient is because you have gas pressure. Gas is constantly being introduced at the surface level. Most of the gas is coming up from underneath the surface, and we have an electric gradient going up 100 volts per meter on the Earth. So if the Earth is flat and contained, that's exactly what we would have. Okay.
This one
And
coming in
you would
from.
have gas pressure
I've got
without
to give
a
Austin the
solid
last word on
container.
that one because the question is for him.
Right.
This one coming in from Down in the Rabbit Hole says, good to see you down in the rabbit hole, says, do you think globe cultists will ever admit that zooming in on a terrestrial object from a terrestrial position is completely different from zooming in on a celestial object from a terrestrial position? You can't zoom it back. I can read that again. Would you like? They say, do you think globe cultists, like Taylor, will ever, I'm just kidding. Say, do you think globe cultists will ever admit that zooming in on a terrestrial object from a terrestrial position is completely different than zooming in on a celestial object? So celestial object rather than terrestrial object. So in the first case, it's terrestrial object being zoomed in from a terrestrial position. And now they're saying, don't you think, are you willing to admit that that's completely different from zooming in on a celestial, so with a C, not terrestrial, but celestial object, from a terrestrial position that you're zooming in from? They said you can't zoom it back.
I'm not sure what he's saying. They can't zoom it back from, but yeah, there are differences. I'm not sure what differences he wants me to state there are. But I don't know. I guess the one comment I have is the reason you can't zoom back things that go over the horizon from that are on the terrestrial level is because of the curve. And the curve does not rise to the actual horizon line, which you would expect from linear perspective.
You got it. This one coming in from Annie Purdue. Let me know if I say this right. They say, nowhere in my flight training was I taught to fly as if the earth was flat. Instead, I was taught the four forces of flight, which imply the presence of gravity.
But how come whenever you were trained, they had to negate the gravity vector and you don't ever have to account for it when you fly? No one, it's a ridiculously egregious straw man to say that we are saying they teach pilots in pilot school that the earth is flat. No one's saying that. It's that when you fly the actual plane, you do not personally account for curvature or spin. You fly as if you don't have to worry about that. And you do also not have to make any type of accounting for gravity other than weight itself, of course, which is called lift. It's a plane. So yeah, you have to fly the plane like it's flat, bro.
I'm just not understanding why you would have to account for those.
Because the ground would be dropping down beneath you, bro. And if the earth is spinning, I'm going to land on it. If I'm landing on it going west, then I'm going relative to the earth spin. If I'm going east, I'm going relative to the earth spin. But we don't have to account for any of this. North, south, east, west. We land on runways every which way. We get to fly the planes as if the earth is just sitting there perfectly still and it's completely flat, but actually it's spinning and curving and gyrating sideways and going around the sun and all this other nonsense. So it's just, the answer is relativity fixes all of your problems. That's the answer. It makes it look like it's flat.
Even though it's never been scientifically validated.
And it's a reification fallacy. You can't treat physical properties to conceptual abstractions, including a privation, which is the absence of anything. So it's actually stupid lunacy on its face.
This one coming in from, do appreciate your question. Perpetual Motion says, if Chile and Greenland, and that's... If Chile and Greenland are separated by 8,000 miles, this is, folks, you got to do me a solid. Sometimes it's like the I don't understand. So I'm going to read it just as it is. They say, if Chile and Greenland, that's separated by 8,000 miles, is seeing the sun, while New York City, so I think they're saying like if both Chile and Greenland, which are separated by 8,000 miles, are seeing the sun, while New York City, that's 500 miles west, is in the dark. How does that work on a flat Earth? Turning a ball in front of a lamp solves it.
Man, oh my goodness, man. It's called light attenuation. Light does not go on forever, and I've explained about 4 times in this debate. There's something, which, to be fair, maybe super chatted before, unlikely though. It's called the circumference of light, based on the divergent rays. There's Rayleigh scattering of light. Okay, it's a well-known phenomenon, and so is attenuation of light, an absorption rate of light. So the idea that the light should go on forever is ridiculous and antithetical to physics that we know exists. It's called a straw man.
This one coming in from Daniel Hagel, says, just here to say you got to get David Weiss Flat Earth Sun Moon Zodiac Clock app in the App Store, presumably, on Android and Apple devices. Love you, Dave. Oh, I think they're saying, Dave, we hope that you get this app so that it can be used on Android and Apple devices. Let me know, Dave, if I got that right. Or Daniel, let me know if I got it right. Robert Summers says.
Sorry. I was going to say, take the Flat Earth Challenge, watch the video of the day for 2 weeks, and you will definitely probably question the globe, at least, or be a flat earther.
This one from Pivot Cyroy says, shout out to the builders of the Dutch, let's see, Afsluitdijk, one of the longest dams in the world, which you can clearly see curve over the horizon, and which is calculations take into account the Earth's curving during construction.
Every single time that people say this, it's not true. They don't actually account for the actual curvature rate, nowhere close to it at all whatsoever. You can't even build things if you don't maintain level. Secondly, where you claim it's going over the curve of the Earth, that's going to change every single day. So is the Earth breathing in and out? Or are you going to see more of the dam at one point? How does that work? It's because it's all based on atmospheric conditions. So the atmos changes throughout the day. It changes how much you can see. The Earth doesn't breathe in and out. So the dam isn't consistently obstructed by a physical location every single day, and the same amount of the dam is hidden. That's just patently false. And they do not account for 8 inches per mile drop either, because that would be absurd.
You got it. And thank you very much for your question. Robert Summers says, so the answers to my questions were to, in all caps, assert that flat Earth is some kind of tornado or something, and that all astronauts are baby blood drinking Masons. Evidence for that?
Oh, okay. It was just a joke. I don't know if they actually drink the blood of babies, but they are typically Masons. Some of them don't admit it, so yeah, that would be speculation. But they all like to throw up I can't even do it. RV Truth will slaughter me. But they throw up the signs consistently. So the point is that, yeah, I wouldn't be allowed to be an astronaut. But what was the first part of the comment? Not the blood drinking part, but the
a tornado.
Oh yeah. So no, I didn't say the Earth is a tornado. I get you're trying to be facetious, but it's that's a good analogy. A whirlpool, a tornado, of how it's wider, then it gets tighter, because that's the vortexual movement in the ether. And the actual ring laser gyro you guys use to measure the Earth's spin was discovered uses the effect called the Sagnac effect, discovered by a guy named Sagnac, which said it was the vortexual movement in the ether, which also explains the Michelson-Morley. I was explaining the movement of the field of energy over top of the Earth that you're detecting when you look at interferometry patterns in its ring laser gyro.
This one coming in from, do appreciate it. Cana Bear says, boats don't fall over the edge of an imaginary curve horizon. You can see much further than globe model sphere calculations. The globe model was created using flat Earth elevation angle measurements. I think, Cana Bear, we read that one earlier, but I don't know if you missed it, but we did. Maybe you went to the bathroom, but we'll give you... this was exactly the same one that I read. But so if you guys want to respond, let's humor them because they really want to hear your response to this.
I think it was a little bit different. But yeah, I don't know how you get a globe from flat Earth measurements if it's flat. How is it producing a curve? And the reason you can sometimes see further than the calculated curve of the globe is atmospheric refraction, which can make the curve appear less curved, but cannot make flat appear curved.
Gotcha. This one coming in from Shane from Kentucky. Thanks so much for your kind words. Says, James, you're a legend. Thanks for all you do. Seriously, thanks. I really do appreciate your support. And also, I gotta pass the credit on to the guests. The debaters, the guests, are the lifeblood of the channel. We appreciate them so much, my dear friends. I've got to tell you, they honestly make this show awesome. And so we want to say a huge thank you to them. And Amanda sent in I've got to put this in the old description box because I mentioned it once, but nobody, I hadn't put it in the description box. We have on Modern Day Debate is on Venmo. In case you are like, listen, I want to submit a super chat, but I don't like supporting YouTube because, YouTube takes 30% of super chats, like right off the top. And so if you're like, hey, I don't want to, I'm not really big on giving more to Google, that's fair. We do have a Venmo, and I'll put that in the description box. But Amanda said, don't forget to smash that like button. Thank you so much for your support, Amanda. Seriously, that really does mean a lot. We are encouraged by that. And it's true. Don't forget to hit that like button. We really do appreciate it when you do support the channel that way. But one last thank you. Austin.
Dave, have you ever considered reading the questions that they send off YouTube? Like if they PayPal'd you or Venmo'd you in a question, that way they'd still get the perk of just an idea. I try to kind of do that because they take too much of it, man. The little grabblers.
100%. Yeah, that's what I was saying is that I'm going to put it in the description box so that way people can access it in the future, is that we do have PayPal and we do have, we'll put that on the top of the description box just for anybody who's out there, and we'll make sure it's like always in there because some people, I don't blame them. I think everybody in some way, frankly, I think YouTube tends to go after any extreme view, no matter which direction, like politically, for example. Like if you are far enough left, I think that YouTube may actually censor you. And I think if you're far enough right, YouTube will censor you. And so I think I sympathize if everybody has a little bit of skepticism about YouTube. I think that YouTube's trying to please the mainstream. And so anybody too far out in any direction, YouTube, I think, is not always
dropping the hammer.
Yeah, but I want to say, Austin, Kai, Taylor, and Jen, it's been a true pleasure to have you.
Thank you.
Thank you so much.
They're linked in the description, folks. Do you want to hear more about their views? I bet you do. I mean, you've been listening this long. What are you waiting for? So I'll be back in just a moment with updates about upcoming juicy debates that you don't want to miss. So stick around, and I'll be right back, folks.